This conference will now be recorded.
So today we will be talking about a very important topic called DynamoDB. So DynamoDB, why it is very important? Because it's a NoSQL database. So whatever that we saw in the RDS services, they're all SQL-based database. When I say SQL-based database, they all have a rigid schema. There are sometimes some kind of relationship between tables, right? When we create two tables, or even within your application, there may be n number of tables. All the tables in some way or the other might be linked or might be having some relation, right? Say for example, I have an employee table. Some employees joining a organization. What they will do, they will have one master table where it will have employee ID, employee name, and all those details. And suddenly, say for example, you are in the AWS project. So what they will put, again, they will have a link that to that employee master table saying employee ID 001, and he is in AWS project, right? For example, there is a project table. So the project table and the employee master is linked using our primary key, employee ID, right? Employee ID is unique for everybody. So that will be the primary key. So this is how your relational databases work, and we have relations between each and every table. And there are also fixed or rigid schema. So what do you mean by fixed or rigid schema? Let's just quickly see this, right? So let's see. Let's say for example you have a table called employee, right? So suppose whenever I create a table, okay, I have to define its columns, I have to define its schema, right? That's what we do normally. So say for example, I just say ID as one column, right? And then name as another column, age as another column, city as another column, right? So this will be my table creation. So when you try to create a table, you will define the schema saying these are all the columns that you need to have, and each and every column you will say what data type it is, whether employee is a number or string or whatever it is, right? This is how normally we create a table. Like this is a table this has a rigid schema. See, whether when you enter the value can be like this, right? Your employee ID can be 1, your name can be this one, your age can be this one, and say for example you don't know what is the city, it can be null also, right? It can be null also. But the only problem is all this one has to have some value, whether it is null or not null, you should have some value. So that's a rigid schema, you need to follow this, whether you enter the city or not or some other field, it should be at least null. So something should be there. So they're all fixed. Now what happens, I need for one employee, I need like this, right? I need like this for one employee. So EMP name, and for one employee I need EMP salary. Okay, for the other employee I need EMP ID, and I need EMP name and EMP say previous company, right? Previous company. And for another employee I just need employee ID, this MP name, and just say experience, number of years of experience, right? For example, something like this. Right? For another employee, I just wanted to add only employee name and employee ID and his name alone, right? Is this possible in our normal this one? That's not possible because we don't have a rigid schema. See, the schema keeps on changing, right? The schema gets changed every time I create a row. So I can create this one. I want separately. For another employee I need this one, another employee I need this one. In this case we cannot do, because this is a rigid schema. All the employees need to fit into these columns only, right? So this is where your NoSQL comes into picture, right? So this is called NoSQL, and there are a lot of databases we have for NoSQL, like MongoDB is one, that is a NoSQL database, and we also have a DynamoDB service within AWS, which is a NoSQL database. That is what we are going to see, and how it is useful and why it is useful, right? So DynamoDB is a NoSQL fully managed database as a service product available within AWS. It is used for our serverless or web applications. DynamoDB is a NoSQL public database as a service, so it's a public service. So it's just like our Amazon S3 is a public service, not a global service. Similarly, DynamoDB is also a global service. So it is capable of handling simple key value or documents such as DocumentDB. It is a white column key value database, and no self-managed servers or no infrastructure, nothing is there, so you don't have to maintain anything. So all the admin head is reduced and everything is taken care by AWS. DynamoDB is highly resilient across availability zone and also allows global resiliency. That means you can create your own global tables and you can kind of have a resiliency across regions and all those things, right? So it's highly resilient. It's very, very fast. Okay, it's very, very fast, and it provides single-digit millisecond latency, since they're all in the background. They're all solid-state drive-based. SSD means solid-state drive-based. Today, if you see, the solid-state technology has been solid state drive is the one that is actually coming in all our new laptops and desktops, so that your operating system boots very, very fast. It allows backups and point-in-time recovery, so you can take backups. Then it allows something called point-in-time recovery. We'll see what is this, and it also supports encryption at rest, just like our normal RDS database. It supports event-driven integration, do things when the data changes. It's very, very important for DynamoDB, right? So what happens when you try to insert a column into this database? You can invoke a Lambda function, what we saw yesterday, right? So we can invoke a Lambda function from there, and you can go and do an event-driven architecture. So whenever something enters by this one, you do some processing. That's what you can do. So you can kind of play on those streams that are coming inside your DynamoDB. So DynamoDB, there are no databases here. Okay, just keep in mind, there in the normal Oracle or SQL, what you will do, this is a table, yep is a table, whereas your database name might be my database. My DB is your database name. Inside the database only, you will have multiple tables like employee, then vendor, some tables you will have, right, like this. But here, there are no any databases. You straight away play only with the tables, right? You only play with the tables. So this is the table. A table is a group of items. A row in the table is called an item. A row in the table is called item. So in our case, if you see, okay, this is one item. If you enter some value here for somebody 001, okay, and you say some name, okay, and you say salary 12,000, okay, this is one item. This is one item. Similarly, when you enter the other one, right, it can be anything, right? It can be even this also, like I can say 002 and I can say Suresh. This is one item. So these are all items in the table. Each row is called as items. Each row is an item, but very important, there is a partition key. There is a partition key, and there is a composite, or you have a sort key also, optional sort key, a mandatory partition key. One of the field in the item should be unique. Okay, that is a partition key. That is a, so for example, in this case, it might be employee ID might be the unique key, right? Keep in mind, this one row is called one item. An item can be maximum of 400 KB. Item can be maximum of 400 KB. It will be very well within that, because we are only going to store only the key value pairs. It doesn't matter. You are not going to store blobs and other things here, right? So that is where it's just a metadata key value pairs. And then, as I told you, each item must have a unique value for primary key and sort key. Sort key is optional. Okay, so either you can have none, all, mixture, or different attributes. So this is what I told you, right? So for this first item, I can have two columns. For first item, I can have two columns. Second item, I can have three columns, are different, totally different. I can have 10 columns, totally different, right? So that is what it says. But only thing is, make sure that the primary key or the partition key is where you have a unique value for the primary key and sort key. Sort key is optional. Okay, sort key is to narrow down further your search, but sort key is optional, but primary key is mandatory. And then DynamoDB has no rigid attribute schema, as we saw, right? So I told you there is no rigid schema, so you can go ahead and define whatever you want on the fly dynamically, right? Dynamically. Then how are we charged for this DynamoDB table? I don't have a server, I don't have anything. So the only thing that we will be doing is, there are two types of capacity speeds. that are set on the table: write capacity unit and read capacity unit. A write capacity unit means when you write 1 KB of data per second is called 1 WCU or write capacity unit. Reading means 1 read capacity is equal to reading 4 KB per second. 4 KB per second. So this is how they charge you. We will get into and see the pricing for this, but this is how they charge you. When you hear the term in the exam as write capacity unit, read capacity unit, think about DynamoDB tables. Okay. Okay, now let's see some use case, right, where this might be very useful. I'm saying it is very fast, like milliseconds latency, bit latency is there, and it is very no rigid schema, it's dynamically fluid. Then where we will be using this, right? Say for example, let's take that today is Sunday, and today at evening 6 o'clock you are having a gaming company, and you are announcing an online gaming event worldwide, right? People will log into your account and they will start playing the game, right? What will happen? There will be millions and millions of users logging in from all over the world and playing your game, right? While playing that game, you have to show them in the page who is leading in that game, right? It's a game. So what they do, somebody, say for example, it's a cricket, some football game, right? One guy scores a goal, you say that, okay, Suresh has scored 1 goal. Then another time, Anand has scored 2 goals, so Anand will go on the top and Suresh will come on the second, right? So you keep that leaderboard keeps on changing dynamically. So for these kind of workloads where the table data keeps on getting dynamically changed back and forth, you will use this DynamoDB table. It can hold millions and millions of records, and even to retrieve the record, it is also very, very fast. So and you also have an option to trigger a Lambda function whenever the event comes in. So whenever Suresh comes first, his record comes into the database, it will kick off a Lambda. Lambda will go and update another table, which will take it from there and show the leaderboard Suresh is first. And next second, rather, Ganesh might be going on the first, right? So it keeps on, leaderboards keeps on changing. So all those things that can be done, very, very key things that you can do. And not only that, leaderboard kind of thing, telemetry, right? Telemetry data like from GPS. Suppose you are owning a Hyundai car, right? And you are collecting all the details of the GPS information of all the Hyundai cars that are running in your area, correct? If you are actually some company providing some solution like that, right? So or to get the all telemetry data, you don't know where your car is, right? One owner can be in one place, another owner can stay idle in the home, another owner can be somewhere far off, maybe in under the foothills of Himalayas, who knows, right? So all this data will come in different format, right? It need not be in the rigid schema. You cannot always say whenever a driver goes, what is the driver name? You cannot predefine the data. Okay, we don't know what he is doing, where he's going, what songs he's listening to, so many things we don't know. All these are all called telemetry data, right? So these data all can be flowed into DynamoDB for processing and stuff. That is where they use, not only for this, even for the deep space network, right? Deep space network, when this DynamoDB table is used even for Mars probing and all, right? Storing data from Mars, right? Those probes send data to Earth and they will store that in the DynamoDB table. They are all very rigid and fluid, and each and every 0.001 centimeter that the probe goes, they will collect the telemetry data and put it into DynamoDB for further processing. So this DynamoDB is such a kind of very powerful and very dynamic and fluid, so you can use it anywhere that you want, right? So that's very key here. Don't just go for a normal table that we used to create in our database into DynamoDB table, right? That case you pay a lot for DynamoDB table, but still you end up doing the same work just like our normal Oracle SQL and other stuff. For those, go to, if you know that this is the rigid schema and I have a table, this is how my structure is going to be, please go to RDS. Don't waste money by going into DynamoDB table, because DynamoDB table, the write capacity and read capacity unit, the charges are more compared to your RDS. But still, if you are looking at the performance wise and millions of records, then this is the option that you need. Okay. So DynamoDB on demand, there is an automatic backup that is taken. You don't have to do anything. And then there is you can also take an on-demand backup. It's a manual backup. Okay. So when you take an on-demand backup, it's going to take a full copy of your database and you can restore either to the same region or across region or with or without indexes. And you can also change the encryption settings while restoring the backup. On-demand backup is taken manually, as we saw that. So this is just a manual backup. Automatic backup will also be taken, and you have something called very interesting point-in-time recovery. DynamoDB has a PITR, that is called point-in-time recovery. So what is this point-in-time recovery? Suppose if something happened to my DynamoDB table or something, right? What I need to do? You need to enable this per table. Okay, you need to enable this per table basis. Then what it will do? It will start storing all the data up to 35 days. Okay, from today to the last 1 month, 35 days. So suppose if my data, now my table gets corrupted for some reason, right? It gets corrupted at, say now it's 7:30, right? 7:30 a.m. it got corrupted. I can say, please bring my data up to 7:15, right? I can have a loss of 15 minutes maximum, right? You can go and bring this one. Okay, and you can also enable enable granularity in your point-in-time backup, so you can backup till the last second that your table got corrupted. Now you can go up to the last second. Okay, they're all very powerful, very powerful, but this will work only when you enable them for the per table basis, right? It is a powerful feature. As I told you, it's default, it is not enabled. Okay, again, there may be some charges related to this, but this is a very powerful, and which means that you will never lose your data, right? That is the idea here. See, for everything, right, you can never always predict that everything will go right as per our this one. So we always need to, as a solutions architect, cloud engineers, we always need to anticipate some failures, right? And we need to design for failures. Even though the product says is 100% it will not fail, right? But still we will have to anticipate and do something for that. And we have to design our system in such a way that it will also handle failures if in case it happens. Then I told you DynamoDB streams. This is very important, right? So DynamoDB streams is a time-ordered list of item changes in the table. So whenever something gets updated, you enable the DynamoDB streams for the table, and based on the DynamoDB stream, you can trigger a Lambda function to do something, some processing, right? Where, say for example, you are having a courier company, right? You are trying to start a courier company. So what will happen? Somebody is coming to your courier office and dropping a packet at 6 p.m. So first, what you will do, you will put an entry saying, okay, this is the courier reference number 0001, and this is the packet, this is the guy who is coming, and it is the source is Chennai, destination is someplace in Bangalore, and then you say this is the time, and say it is we just received the packet in this location. Then what it will do at the night, what you will do, it will go to your central location in your, suppose if your courier is in Chennai, it will go to a central head office in Chennai somewhere, and they will update, okay, it has reached the head office at 8:45 p.m. right? That's what they do, right? And then then they will put it as in transit, right? Your parcel is in transit. Then as soon as tomorrow they receive it in Coimbatore, they will update, okay, the parcel has been received. And once it is delivered, what they will update, they will go and update saying, hey, the parcel has been delivered to the customer. They will close that. Now you have 4 records, right? Now suppose if I want to send an email at every stage, right? So whenever I go give my parcel to the courier guy, I have to get an email, I have to do some processing. How we will do? Go and enable this stream. These streams will go on, capture all the changes over time that has happened, and it will start triggering your Lambda function, and you can go and do that. And again, it is enabled on the per table basis. So it is a 24-hour rolling window. It is enabled on a per table basis. Once enabled, it records all your, only 3 things we can do in a table, right? Either you can insert, update, or delete. Nothing else you can do. So these 3 events will trigger some Lambda function. We will see how that triggers, right? While doing this, while triggering this, you can capture certain views, right? You can capture different views that will influence what is in the stream, right? It has an option in the streams to enable that. These are the 3-4 things that you have. Whether you want to see only the keys in the event, these 2 keys, right? The primary key and the sort key, or you want to see the new image. This is an item which has 5 rows. You have deleted 1 item, so now we have 4 rows. So whether you want to see the new image only with the 4 rows, or you want to see only the old image with 5 rows, or you want to see both the new image and the old image in the event, right? You can select your view types, and based on that you will get the event. So this is what happens when you enable the DynamoDB streams for all the inserts, updates and deletes. It is a 24-hour rolling ordered set of changes to the items. Then it will start capturing this particular views, and you can configure which view you want, right? When you say old and new images, it is costly operation because you are doing a read capacity unit, right? So you read the entire stuff, right? New and old. Old images, you are only doing this one, right? So you may be paying less. New image, you are doing only one key, you are only doing these two, right? So you may end up paying something, but again, it depends on your business requirement. You need to do this, but in our case, when we are demonstrated, we will try to go for new and old, so we know what has changed and what was the old one, right? So DynamoDB triggers, as soon as stream comes, the next is the trigger. So DynamoDB stream is powerful when combined with triggers, right? Well, see, if you enable the DynamoDB streams and don't have any Lambda function, there is no use, right? So what are you going to do the action based on this event? That's what we need to see. It's a event-driven architecture. Item changes will always generate an event. There are 3 events, whether it is an insert, remove, or update. So that event contains the data, what has changed, and action is taken using the data. So you'll have streams plus Lambda, right? Lambda is the very powerful tool that we saw yesterday, right? It's widely used in reporting analytics. It's also used for data aggregation, messaging, notification, voting. If you are having a voting app, right? So whoever puts the vote, you keep on raising this one, right? Say but there is a 2 team. If you go to like some game shows, right? They give you audience, they give you something, right? It keeps on, the voting keeps on changing based on the people they vote, right? So that is how it happens, right? And then stock market is what they will be using all these things. So think about using the database in a very large scale. Right? So this is how it triggers, right? So item changes occur in a table when streams are enabled. Once you enable that stream, then I go and delete this particular value. So DynamoDB captures this particular delete, and you see this new item, old item, and Lambda function is invoked, and it passes this view data as an event to the Lambda function, and this Lambda function can do whatever it has to do, right? Whatever that you prefer as your business process to do, it can do. In our case, we will just print this event and see what is happening, right? Whether we are able to capture the events correctly. Okay. So let's get into this DynamoDB table and just go to this one and see what is there and how to do all these things, right? Please use it for some bigger use cases. Don't just use for a small use case where I need to store 2 tables, 3 tables, and it's a fixed rigid schema. Please don't go for that. Go for RDS. If you don't know the schema and it's a very big application and all those stuff, go ahead and use this, right? So click on DynamoDB here, search for DynamoDB, or you can go directly if you have already visited. It will be in the recently visited page. Go to DynamoDB. DynamoDB, right? You don't have any option to create a database. You only have option to create a table. Okay, so a fast and flexible NoSQL database service for any scale. It's a fully managed key value document database that delivers high single-digit millisecond performance at any scale, right? So that's very, very important. Pricing is also too much. You need to be very careful. DynamoDB charges for reading, writing, storing, everything in it will keep charging. Like for example, I told you, right, the write capacity unit and the read capacity unit, that's what it will charge you. You can go down here and check your charges on your pricing, right, for your this one, right? Pricing for on demand, pricing for provision capacity. You can go and see all those pricing here. Let's go create a table, right? You need to have the name of the table. Let me keep the same yum table. Now, here is what I told you, the partition key. The partition key is a part of the table's primary key. Okay, it is a hash value that is used to retrieve items from your table and allocate data across hosts for scalability and availability. This is a This is a mandatory, right? It can be string, binary, or a number. It can be string, binary, or a number. In our case, let's make it employee ID as our prime partition key. Okay. Then you have a composite key or a sort key. Okay. So this is optional. You can use sort key as the second part of your table's primary key. The sort key allows you to sort or search among all items sharing the same partition key. Sometimes your employee ID can be 001, 001, 2 rows, right? So you can use the sort key to sort that. Okay. So it's an optional. If you want, you can add it. That also has the same data type like binary, numbers, and string. You can customize your setting like this, and you can go for DynamoDB standard, and you can go put all the average item size, how much you will put, and how much read capacity unit, write capacity unit you have. You can go and put all those things in this one, or you can go for provisioned, and you can say I need how many minimum capacity you need, maximum write capacity you need, and it will get charged accordingly, right? This is the default one that is there. So this is what you will get charged accordingly. This is for custom settings. You want to go for default settings because we are not going to have much thing there. We are simply going to have 4 or 5 rows max, right? So what you will have, it's a capacity is provisioned mode. So default you will get 5 RCU and 5 WCU, write capacity unit and read capacity unit. Auto scaling will be on by default, and encryption is owned by Amazon DynamoDB, and table class is a standard class that we have. Tags are optional. Go ahead and create this table. Now, how you will write data into this from your application? You have to call the APIs, say put item, right? Put item, create item, or these are all the things that you will be calling as part of the DynamoDB APIs. The table is now created. Get into the table. Okay, this is the table. Nothing else is there. Item summary. Item is what I told you. Each and every row is an item. So let's go create a new item. Okay, see, employee ID is primary key, partition key. So you already got this, right? So value, this is a number. You cannot change anything here. Let's go and put 001 as a employee ID. I want to add employee name as a string, right? And I call this guy as MEMP name. And I give a name for this employee. Okay, just see how powerful this is. I'll create an item. So my one item has only 2 rows. Okay, that's fine. Let's create another item. Okay, and I call this one, right, 002, and I'm going to add his name, Suresh, and I also want to add his employee city, right? Employee city. Okay, I also want to add his employee age. Okay, something, right? And I also want to add a boolean. Okay, has underscore experience, right? Has underscore experience. Yes, he has experience. Okay, something. This is just a table kind of thing, right? That you wanted to set. So like this, you can keep on going and adding all those things that you want. So now see here what happens. The second row is entirely different. See here, the employee for second is entirely different. Now this schema is different. This schema is different. This we cannot do in our normal regular RDS, right? So RDS, what will happen? Here it will be null. It should, you have to define everything, and this all will be null, right? So this is the power of your this one. Now I can create another item with employee number 003. Okay, and I can simply go and put, I don't want anything, just say employee salary, or say employee address. Okay, employee address. I just say A4 Chennai. That's all, nothing, right? And I also go and add another number saying employee salary. And I put some numbers here, right? We put some numbers here. Okay, 4,000. Go and create a table. Refresh here. See now what happens. This third guy has only this one, right? See, employee salary 4,000. So this guy has only these 3 fields. So like this is the where when you don't have any rigid schema, this is what you all can do. Okay. So now I am consuming my write capacity unit. Okay. I am consuming my write capacity unit. You can go and query the table, okay, M table, and you can give filters you want, what you want to filter. You can filter by attribute name. I want to filter by attribute name, M ID, and that's this one, and equal to value, this one, and say add a filter and go ahead and say run this. You will get, if you simply run the scan, it will list all the three. So you want to see specifically for something, you can run, but again this scan operation also will cost you more because scan will read the entire table. So as I told you again, your write capacity unit will come into picture. Okay, so this is what we have for your employee table. Now let's get into this employee table and see all other different options that we talked about, right? So you can create indexes. You can create global index where the reading of this one will be faster. So it's just like creating views in the normal table, right? You can create indexes so that search will be faster. And then all these are monitored using CloudWatch. CloudWatch metrics automatically watches all these things for you. See here, read usage, read throttle, and all those. See, our read has been exceeded here, right? So you can see all these things: write usage, write throttle request, latency, and all those things that you can see here, right? The scan latency in milliseconds, time to leave, everything that you can see here. Scan and query, what did you do? Errors, if there are any, that you will get it here. Any transaction that you did, that everything will be here. So all this are just the summary of what you see. But if you go back to the CloudWatch, you can directly do, and also you can create an alarm based on these things, right? You can go to this one and say, please, if something my read capacity reaches certain threshold, please go ahead and do this. Or if my scan query is more than 2 milliseconds, send me an email or do something that you can do. And here, if you turn this on, enable CloudWatch contributor insight, when you go to CloudWatch, it will show you some, give you some insight based upon the data that is available within the CloudWatch. Okay, so this also you can do. So these are all something you can do. You can view this, the entire logs in the CloudWatch metrics, right? Let's try to open this and see if we have any CloudWatch metrics, right? See, the namespace will be used as DynamoDB, AWS/DynamoDB. We saw this already. Okay, so you can go to table metrics, and this is a table that you have all those metrics, right? So you go and select this guy. It will say you if there is something, see here, something is coming out here, and you can go ahead and do all these things, and using some actions you can add to dashboard. You can download a CSV, check all those details. It's up to you, right? So global tables, you can create global tables. You can create a replica. So where other regions wanted to have this replicated table, you can go and create a replica and create it in another region, right? So you can do that also. You can create the replica. This is the current region. You want to create the same table in, say, Sydney. Please go ahead and create it, right? Again, for replication to work, DynamoDB streams will be enabled automatically for new and old images, which indirectly will increase your cost. Okay, should be very careful. Then very important, coming back to backups, right? See, there are no backups here. There are automatically the backups are enabled, but we have only option to enable the point in time recovery, right? Point in time recovery, or we can take an on-demand backup here. You can create a on-demand backup here, or you can schedule a backup. These are all manual backups for us. These are all manual backups. You can go and create a backup. You can select which table and give a table backup name and create a backup. It will create a backup and keep it for you. That's a manual backup. It's going to take a full backup. Or if you want, you can go and schedule a backup like this, right? You can go and schedule it. So you don't want to do every time manually. You can go and schedule this backup. Even though it is doing an automatic backup, as a designer, you will have to make sure you also take the backup correctly, otherwise you might lose. So daily 35 days retention, monthly 1 year retention, weekly retention, or 7-year retention, right? So daily, weekly, monthly, 7-year retention. So daily it will take, and it will keep for 35 days or 1 year or 5 year or 7 year, whatever retention. Or you can build your own new plan, or you want, you can put all your details here and create this schedule, and it will automatically start taking the backup during that point of time, right? Okay, you can backup and send all your data to your this one. Okay, so this is what you can do in the backup plan. This is actually AWS backup. It actually goes to the separate service for backup, and you have to do your backups there, right? So just make sure you are deleting this backup. Okay, if this is not there, then it cannot take a backup. So EFS backups and all those things that you can take if you have something. Okay, we have to do it as a root account only. Okay, so you can go and create some schedules and all those things using AWS backup as a service. Then very important is what we saw about this exports and streams. So you can export the data to an S3 bucket. You can create an S3 bucket, export this data there, and use it for something else. Or you can send it to another Kinesis stream. Kinesis data stream will capture all the item level changes and send it to Kinesis, and that will process. Amazon Kinesis data stream is for your data warehousing. So now huge number of data is there. You can pass it through this one also. So everywhere it will say charges apply. So please be very careful. Now you can also enable DynamoDB streams as we talked about. These are the views we have. Only keys, new image, new and old image. Let's put new one, old image and do the stream. As soon as you enable the stream, it will ask you for the trigger if you have any trigger, right? Let's go back and create a trigger there now. And let's see what happens when we play around with our the items that we have, right? So I'm just going to call this as DynamoDB function. DDB is DynamoDB, okay, and it's going to be my Python. It's up to you, whatever language you want to put, you can put it. It will create a role, and we need to add additional policy. This role only will create policy pertaining to CloudWatch, but we need to add additional policy to access your DynamoDB, right? So let's go and create this function first. Just give it a minute, then it will create this. Okay, just go ahead and simply say print your event, right? That's what we need. We need to know what event is getting passed and how to do it. Deploy this. Go back to the configuration. Okay, go to the permissions. Open this role in IAM. Just see what permissions it got. Only this one. Try to open this. It will only show you that it has access only to the CloudWatch, nothing else. This function has access only to CloudWatch. Let's try to add this function here and see what it does, right? So I want to choose a function. I have this function, batch size. Batch size means whenever the stream happens immediately, do you want to trigger the lambda, or you want to wait for 10 events to happen and set it as a batch, right? So you can go up to 10,000 batches. So the better way is to always keep some limited number, because if you make it one, what will happen? Every time the event happens, it will go and trigger your lambda, where invoking the lambda also there will be a charge, right? But for now, since we have only few records, I'm making it as one, but it's always better to have 10 or 50, something like that, right? It will wait for some time to trigger that. And make sure you enable the trigger. Create this trigger. It will throw an error saying invalid parameter because it cannot access the stream. You don't have any permission to access the stream. So what we need to do, either go to that permission and add specific permission of DynamoDB like this into your IAM role, or just go and add the DynamoDB full access. Let's go back to IAM, okay, and let's close this and add a permission, attach a policy here, and just search for Dynamo, right? Amazon DynamoDB full access. Okay, so you can also put this, right? DynamoDB execution access, which will specifically have all these things, right? Get shards like this, right? Here we are saying, see here, get records, get shard, iterator, describe stream, list stream, right? These are all here. So either you can apply this one, this role, or that one. Let's go and apply this role itself, right? Let's put this role. Attach the policy. So what will happen? Your now DynamoDB has two your Lambda function has role which has these two policies. Now go back and see if you can create a trigger, right? You are able to create because it has the right permission to access the stream. Okay, now what are we going to do? Let's go back to our table or explore item, right? Go to the table, click on this one, okay, and where is the item? Whatever I missed this somehow, right? Okay, so I've enabled the streams now. I'm going to create a new item and let's see if that it's getting triggered, right? See, as soon as we add, this trigger there automatically. See here, what is the trigger now? DynamoDB will be the trigger. DynamoDB will be the trigger. Let's go and say this employee ID here is 005, and we will just put only the kind of string and say employee, what to say, right? We'll give some name, right? So something which is entirely different, right? Employee tax, okay. Pay tax 1,000 rupees, right? Create item. So as soon as you create an item, there will be an event that might have gone inside, right? That might have gone inside, right? That might have gone inside, and see here, employee street, Radon street, and 1,000. Now go back to your log group and check if it is triggered. You will get a log group created with the DynamoDB function. See, DynamoDB function has been done. Go and click here and go to the log stream. Copy this record. Go back here and just put this guy, and you will be able to see here. Event name is insert, right? We inserted. Okay. It is a new image. What is the new image? Employee ID number is equal to 5 and employee street. This is Radon street. Tax we gave some 10,000 rupees. Here is where your new images. Okay, new and old image we got. This is an insert, so you will always have only the new image. You will not have the old image. Okay, now let's go and update that table and see what happens. Right. This is the way that you can go and process based on different events from DynamoDB. Now go back to that same table wherever we had. Go to that 5. Okay. Now what I'm going to do, I'm going to add another number saying tax refund. Tax refund. So now for him the tax refund will be 1,000 rupees, and the total tax he has to pay will be like 23,000, for example, right? Something, just something. So I'm trying to update an existing record. Okay. Now go back to your CloudWatch. Just give it a minute. It can either be the same stream or a different stream also. So just hold on for a minute. Okay, it's the same stream. Go back down and just copy this, right? And go here and paste this guy. See here now, your event name is modified. The first thing it was insert. Now it is modified. Now you will be getting both old and new, right? So let's go and see. This is the old image. What we had, the old images, we just had employee street, Radon, taxes 1,000. Okay, And what about our new image? Is this is your new image. Street radon tax refund we added, and tax is 23,000. So this is your old image, this is your new image. What are these S and N? They're all data types, string, number, right? String and number. So this is what happens. DynamoDB streams happen. We just printed this, but you can write a lot of logic here to do certain things, right? You can update another table if it's a leaderboard. So if Suresh has scored 1,000 points, then you trigger a lambda and update another table where it says on the leaderboard, Suresh, number one, Suresh, 10,000 points. By the time you upload, right, Ganesh might become 20,000 points. So it will keep on happening within seconds. This is what is happening, right? So this is how you go enable your streams. Now, since we have done these two, let's try to do the other one also that is available, which will simply go and delete one of the item, right? So I want to delete item number 1. Delete an item. Delete an item also will have to trigger the lambda. So whatever you do in that table will be triggered. That's all. Click on this. Okay, we are already here. Copy this, go here and paste it here. See here, modify, insert, modify, remove. These are the only 3 operations I can do in any table, right? I can either insert a new value, I can update an existing value, or I can delete an entire row. So this is an item, and each row is an item. Each row is an item, right? That item cannot be, it cannot cross 400 KB, right? So this is what has happened, and this is what we have done. Okay, and stream view type is view new and old images. So that is what we saw here, right? We are triggering this new image, old image, and we are able to get all these things. And whenever you do a modify, update, insert, you are getting this view types, and we selected the last view type, so we are able to see new and old images. If you select first one, it will only show the primary and sort key. That's all, nothing else, right? So this is what your DynamoDB and Dynamo. When we talk about DynamoDB, the streams are very, very important for DynamoDB. Okay, please keep that in mind. And if you see there are some additional settings you can do where you can go auto scale your read capacity, write capacity based upon how your read capacity and write capacity happens, right? So you can say when my read capacity reaches 70%, please provision another read capacity unit, right? You can go and say that for that, right? This is a kind of auto scaling kind of thing only, nothing else, right? So these are all some of the activities that happened right from the beginning that we did. So we have written, we started writing, we started reading, we started writing, right? So all the events will be captured here, and this is a time to live. Automatically delete expired items from the table. So set up this time to live, so the data will be there in this only time to live. Okay, you can set up an encryption for this. You can either manage and owned by Amazon DB or a managed key, or you can store your own key, and you can encrypt those table items here. This encryption is for this table. Then you can add additional tag to categories in your billing account, right? So these are all the things that we have for this one. Apart from that, you can also have some particular editor. There is an editor, you can write your query and try to edit, and you will see all those things as a. So if you know how to write a particular, you can go and write that. Then any backups that you take manually will be here. If you would have taken the backup, please make sure you go and delete here, right? Otherwise this get charged. And you can export the data to the S3, and you can see all those details here. And you can also have data from there and import it into our this one. You can import it as a JSON file or something like that, right? And then you can reserve the capacity for your this one. So you can purchase a reserved capacity, and that is where you say standard reserved read capacity. I need always 10 read capacity, reserved 10 write capacity. You have to pay accordingly, right? Okay, so this is what we have. So DAX is nothing but DynamoDB accelerator. DynamoDB accelerator is a accelerator is your DynamoDB accelerator will actually accelerate the data that is moving to your edge locations and stuff, right? You can use this to configure the DAX. This is actually out of our scope for this particular mission, but just know this is called DynamoDB accelerator. Okay, so this is what we have for our DynamoDB. Any questions here, guys? So we don't have any database, we only have tables, right? We only have table. You can create a table, you can get inside and you can start doing all these things. You can edit the capacity, you can update the table class, you can delete the table, you can create item, you can create index, you can create replica, you can export it to S3, you can enable the TTL, you can manage your tags, you can create access control policy. Who can access your DynamoDB table, right? So these are some of the things that we have this one, and we saw what are this index, how to monitor, what are the monitors, then backups, extremes, exports and streams we saw, and all those things you can see here. Now let's get into this table, right? When you create an item, there are two types of ways that you can create. Either you can go keep on entering in this form, or you can create one JSON file and you can go and enter. So create a full JSON file and go ahead and paste it here and create an item. It will create an item there for you. Okay, so this is what will happen for you. So you can either do this way, or let's put this right and say my employee ID is 008 and I put some name here. It need not be emp name, it can be any name, right? It's up to us, because I told you there is no any rigid schema. So all that you just need to degree false. Okay, create this item. Okay. We'll go back to this guy and go and see this is what the JSON structure for this particular record is. Now again, the DynamoDB might have triggered Lambda because our streams are still enabled. So if you go down and see here, you will still see the new one that has come in, right? With the event name as, so this is the old one. Just hold on for a minute, you will get it. New stream is created. Just go over here and copy this and put. We will be seeing whatever we have just created. So it's an insert and you have Ashok, right? So this is what you can see, right? So like this, you can go insert it in the form, or you can insert it using your JSON file. Now, if I have a lot of records, what they will do, they will create as a JSON file, very big JSON file. How they will create a JSON file? They will have the data in your Excel. Okay, so these are all the programmers work. They will have data in the Excel. They will write program to read the Excel and create the JSON and pass this JSON into our create item event, right? They will do that and they will create it dynamically, right? That's how all this is being done. Okay, so this is all our DynamoDB. Okay, let's quickly any questions that you guys have before we go and clean this up? I'm going to delete our lambda function as well. I will keep this lambda function, okay, because the next is what that we see that also we need to do. Let's go and delete the table. So it will delete all the CloudWatch alarms for this table and ask you to create a backup. If you select this, it will create a backup and keep it there. And since it's just we are learning, we don't want any backup for now, because unless it will get charged, right? It will delete and wait for it, then it will go off. That's all. So your DynamoDB is done. Okay, now let's talk about the other stuff that we have, right? So the last service that we have to talk about is your SNS and SQS. SNS and SQS is, SNS stands for Simple Notification Service, where all the notifications happens through this service, right? And we will just see what is that and what is a SQS. SQS is nothing but your queuing service, like IBM MQ, message queuing, right? So or Apache MQ, all these things will use this. So SNS is Simple Notification Service. It's a highly available, durable, secure, and fully managed by AWS. You don't have to provision any servers for this. These are also serverless services. It is a publisher subscriber messaging service. So it uses the publisher subscriber model. So what will happen is, for SNS, you need to create a topic, and some system or somebody will publish a message, and you have multiple subscribers who have subscribed for this message, and you will get a message. It's just like what you do a subscription for some site, right? You go and subscribe there, and whenever they release some newsletter, you will get an email. That is what will happen. And one topic can have multiple subscribers. A subscriber can be an email, and it can be an SMS, or it can be a Lambda function also, right? That's what we are going to see, right? Lambda function also. So what we will do, we will create a topic, we will publish a topic, and we will subscribe to our own email, and our SMS charges will be there. So be careful in putting the SMS, and then go ahead with your Lambda, right? So one message can have multiple subscribers. It can automatically scale, keep messages secure using KMS keys. You can secure it. Messages can go to different subscribers based on the fields in the message. Same message, so based on different people, it can go to different places. Okay, that's called a message filtering. So if my subscriber is Lambda, I need the message to go in a different way. If I'm an email, go in a different way. So, and very important, this is called fan-out architecture. Fan-out architecture means same messages can be consumed by multiple consumers. It looks like a fan, right? So that's why it's called fan-out architecture. When you see the term fan-out architecture, the entire AWS, it's only just SNS. Okay. So similarly, when we talk about write capacity unit and read capacity units, they are referring to DynamoDB. When they talk about OAI, origin access identity, they are talking about CloudFront, right? So there are certain things related to certain terms related to certain services, right? So if you see those terms, you should immediately relate the answers to those services, right? So when they talk about fan-out architecture, they need a fan-out architecture. What service you will be using for this situation? Fan-out means it's only SNS, okay, nothing else. Out of the 300 services, only SNS uses the fan-out architecture. So this is what is going to happen for your SNS. It's very simple. I can say to read about this is very simple, but it's very powerful, right? Similarly, you have something called SQS, that's called Amazon Simple Queuing Service. It's a fully managed message queue service. So here you can have only one subscriber for one message. Okay, message is put in the queue, and some function will come and process this, and it will delete the queue. It will delete the queue. There is no, you cannot have multiple people subscribe to the same queue. Okay, I'll give you one example for this, right? Why this is very, very important, right? Queuing architecture is very important. Say for example, right? Say for example, let's take a small example, and then you will be able to understand. You are having a website where you are selling milk online. Okay, just keep it that way, right? So there is a user who pays, right? Who submits after paying, giving all the information, he will pay, and then he will submit. Then as soon as he submits, what you will do? Two things you will do, right? You will send his credit card information to the bank gateway, correct? And based on whether bank is giving true or false, I mean whether it is valid or not valid, the amount, then you will update your customer table, you will update your inventory, correct? I'm just giving for some example, right? Inventory. And once all this is successful, then you will return back to the customer saying, hey, everything is successful and your milk will be delivered tomorrow, correct? This is what normally we do, correct? So assume that you're selling a milk packet. What you will do, that guy will put all his credit card information, debit card information. As soon as he will submit it, you will send it to the bank gateway. bank gateway will say, hey, this guy is a valid, he has a fund. The bank will always send only yes or no or true or false. It will never send, okay, he has this much fund, he has that much fund and all, right? Nothing it will send. It will simply say for this transaction whether it is successful or not successful, 0 or 1, true or false, right? So once you get true, then you update all your tables here, customer details, your inventory. Already you have 10 packets of milk. Then now you will subtract 1 and say inventory is 9 and send back the information back to the user saying, hey, you have been successfully placed an order of milk packet. It will be delivered so and so date. That's all. Now what will happen after he submits here, right? He has to wait for all these operations to happen synchronously, one after another, and then get the response and send it back to the user. Until this time, this may be in seconds, but still this guy user need to wait there, right? That is why it keeps on going. You need to wait in the site until you get back, and they say don't refresh your page, don't go back and all those things, right? Because of this, right? So now what will happen if the bank transaction takes some time, or bank transaction is fine but there is some issue with your customer inventory table update? What will happen? Your response will return as empty and you will say the user there is some problem, no, we cannot place your order. Then you have to work out reverse to give his money back to him, correct? So all this need to happen. So until then the user need to wait. This is a normal tightly coupled architecture. So the best architecture to do is to loosely couple this and make it asynchronous or parallel. How you can do now? Again, as per the user, nothing different. He will put all these details and key in. So as soon as you put that, what you will do, the first thing you will send it to bank gateway, and in parallel you will put a message to the queue. You will just put a message in the queue saying update your customer inventory table, update your inventory. That's all. Now what you are doing, as soon as the bank returns successful, you will show success or failure to the user, and that user is gone. So this will all happen parallelly because these are all internal to you, not to your customer. Whether you update your customer table, whether you update your inventory, user is not least bothered, right? All that user need is whether he has paid the amount correctly, whether he will get the milk or not. That's all. So all these are separate process, will be processed as a queue. This is called a loosely coupled architecture, and that is where your SQS will come into picture. So user comes in, you put 3 queues, one to send it to bank, one to send it to a customer table, one to for updating the inventory. We would have already written some lambda function which will come and see the queue. Okay, if it is customer table, this lambda function will take that message and process that in the update the customer table and finish it off. Similarly, the other queue, other message will be there to update the inventory. The other message will send back the response back to the user. So in this case, what will happen? The user simply, suppose here if he is waiting for, say for example, if he is waiting for 2 minutes here, for example, in this case he will wait only for maybe 15 seconds or maybe 20 seconds, right? So that is the experience that you will get if you are using a SQS. So this is a loosely coupled architecture. Okay, so very important thing, only this bank gateway, the user is interested only with that, right? Whether you go your inventory, you have 1000 and making it as 999, he doesn't bother about that. But in the first scenario, he has to wait until you complete all your process, right? So this is what the tightly coupled architecture, and this is a loosely coupled architecture, and this is what we are all going now, so that the user's experience is always great. Okay, if the user doesn't, he comes now, something happens with the customer, he will get failed. The next time when he submits again, customer is fine, inventory is a problem, he will get failed. Third time he will never come to your site. Okay, that's what's going to happen, right? So it's always better to loosely couple your architecture, and this is where your SQS come, and all the process can be, all you can change from synchronous to asynchronous patterns using your SQS. I hope you guys understood. If you have any questions, please let me know, I'll show you, right? So there are two types of queues we have, standard queue and a FIFO queue. FIFO means first in, first out. First in, first out. In the standard queue, order is not guaranteed. Okay, when you publish a message to the queue as ABC, it is not guaranteed always the message will be processed as ABC. But whereas in FIFO queue, the order is strictly preserved. That is why it's called first in, first out. Messages may be delivered more than once in a standard queue, right? There is a possibility, see, it is 99% it will not do, but there is a possibility that it may be delivered more than once. Whereas in FIFO queue, the message follows exactly one processing. Okay, there is a deduplication configuration is available where you can avoid duplicate message delivery. It's called dedupe. Okay, dedupe configuration. Then in the standard, nearly unlimited messages are processed per second because it doesn't have to follow any order. Here, only 300 messages can be processed per second with a batching up to 3000 messages per second. Again, the cost also varies accordingly, right? So when you go for standard, it is 40 cents per billion requests per month after the free tier. Whereas in the FIFO, it is a 50 cents or $0.50 per million requests per month after free tier. Okay, so please keep in mind. And even in SNS also, you have both standard and FIFO. Advantages of SQS, as I told you, they're very reliable. You can also create a dead letter queue. Okay, and you can create a dead letter queue. What is the dead letter queue? Now we talked about here a small example, right? Small example, right? Say for example, there is a these three things are in queue, and we have written some lambda function. The lambda function for this one is fine. It has taken to the bank and written everything is fine. The lambda for this function doesn't have any method to process the customer table, for example, right? So what it will do, it will go get this message from the queue, try to process, nothing will be there, it will put it back into the queue. It will put it back to the queue. So you can define how many retries he can do. After the retry is over, so what can be done? It cannot be kept in the main queue every time. So put this inside the dead letter queue. That's called DLQ, right? Dead letter queue. This dead letter queue, once it reaches the dead letter queue, what you can do, you can subscribe to an SNS topic, and that will send you an email saying, hey, there is a message in the dead letter queue, and you have to log in manually and go and check what happened and get that troubleshooted and add it back to the normal queue, right? So that's why it's called dead letter queue. If you are aware of Unix, when you log in as root, right? Whenever you change to root, it says you got a mail in a mail spool, right? And if you go, there's a file called dead letter. Okay, this is a huge file in Linux which has all the queues that are not processed. That's called dead letter. It's the same concept here. It's called dead letter queue. Okay. Dead letter queue you have. So all the unprocessed message can be sent to dead letter queue. This also scales automatically. The messages are secure using KMS. You can convert all synchronous patterns to asynchronous patterns. This is what we saw, right? This is a synchronous pattern. So it is dependent on everything, right? Parallelly, this has to complete, this has to complete, this has to complete. They're all synchronous. You can convert from synchronous patterns to asynchronous patterns like this, right? Asynchronous patterns like this. For that, you can use your this one. One message cannot have multiple consumers. So there is no fan out architecture. Only one message can be consumed by one consumer. And once the message is consumed or processed, it gets deleted from the queue. Okay, deleted from the queue. Okay. Let's get into and see how this SNS and SQS works, right? Let's go to SNS first. Simple notification service. SNS managed message topics for publisher subscriber model, right? Click on this. I don't have any topics created. So the first step is to always create a topic, and we have to publish a message to the topic. There are two types of topics, both here, FIFO, first in, first out, and standard. And please keep in mind, whenever you select FIFO, the file name should end with .FIFO. .FIFO. Otherwise, this will not work. Okay. Standard, you can give any name you want. I'll say my topic. My topic. Okay. And display name is optional. Go and put the same thing, right? Encryption, if you want to enable encryption, go ahead and enable encryption. What are the different types of encryption you need? Access policy. Okay, who can publish the message to this topic? Only the owner, or everyone can publish, or only the specified AWS account can do that, right? As you keep changing, this item on the right side keeps changing, right? Only the topic owner can do. Who can subscribe to this message? Everyone can subscribe. Okay, when I say everyone can subscribe, it will show you star, right? See here, star, everyone can subscribe. Or only a specified account can subscribe. Put the 12-digit account number. See here, I put 1, 2, 3, 4, 5, 6, 7, 8. It keeps on adding that, right? So that is where this dynamically keeps adding that. Then only the requester with certain endpoints. If you have specific endpoints, say for example, when the request comes only from say chandradc.org, right? See here, when the SNS endpoint is chandradc.org alone, they will be able to subscribe, right? So suppose you are having a specific site internal, that's only subscription you want to do, you can go and put an endpoint like this, right? So this is on the access policy. The basic, when you go to advanced, you can write your own JSON file. Now here, this is what I told you. When the message is not published, what is the retry policy mechanism? I can do 3 number of retries, okay, and minimum delay, maximum delay you can do, how many delay retries it can do, and all those things that you can do. Yeah, right. So all the retry mechanisms are here. They're also optional. Let's keep it for now 3. 3 is the default one. Delivery status, right? Log delivery status for these protocols. If you are subscribing to Lambda, you can say whether the message has been delivered or not. It will log into the CloudWatch. Similarly, you can your SQS can be a subscriber for SNS, and for SNS you can subscribe as SNS. For SQS you can subscribe SNS, vice versa. You can do both, right? So this is all the delivery logging status. Then tags, of course, they are all optional. This is for billing purpose. Let's go create this topic, right? So once you create the topic, that is not sufficient. You have to create a subscription for the topic. Who will consume this message? Let's go create a subscription. The first subscription, these are the protocols available. You can send it to an Amazon Kinesis Data Fire host, or you can send it to another SQS, or you can send it to a Lambda. You can subscribe to an email. You can subscribe to another endpoint. You can subscribe to SMS, right? So all those things you can do. Let's go first subscribe to my mail, right? This is my email address. Give your email address. This is my email address, okay? Subscription filter policy, you want to filter any messages, you can go and filter, or you can also send, if you are retrying something, if some problem is there, create a SQS as a dead letter queue and put this message inside the dead letter queue. Go ahead and create a subscription. As soon as you create, this is an important message you will get, because they are within the US mobile carriers have changed their amount for SMS. Okay. I'll go back to my email. You would have got an email saying, please subscribe, right? Confirm your subscription. See here, my topic, subscription confirmation. You go back here, you will see under subscription, it's still not pending confirmation. I have to go to my email and confirm my subscription. Once I click on confirm my subscription, you can see my subscription gets confirmed. So now, whenever I publish my message, I have to get notified, right? Subscription is done. Let's go create a message and see if I'm getting the message. Go to topic and do a publish message. We are now doing everything manually, but normally it happens from a program. Okay, some system will publish a message here and it will go. Suppose, for example, your user as bank is successful, then you invoke this SNS and that will send a notification email to your customer saying that his milk packet will be delivered and all those things, right? This is the message body. So message subject, you can say my SNS subject. Time to live is only for mobile endpoint. Suppose if you are sending a OTP through mail, if your system is generating an OTP and sending it to email, you can say that OTP should be in their message for only 5 minutes, 10 minutes. After that, it will go off. Now, RBI is planning to bring this feature into our OTP when we request OTP from bank for any transaction. That OTP will not be always be available in our message. After 5 minutes or 10 minutes, it will get deleted from our message. Okay, that is a time to live. Okay. So in future, at least in next couple of months, you might see that feature implemented in banks. Okay. So after you receive the OTP for your transaction, that will automatically get deleted after 5 minutes or 10 minutes, because now they're speculating what time to give, right? Because not everyone is like in India is everybody in the same page to use the digital stuff, right? So they are coming up with some alternate ideas, but the main idea for this TTL is to make sure the only for mobile endpoints, if you do this, the push notification has to deliver the message to the endpoint. Now, what payload you want to pass, right? The message body. You have multiple subscribers. You have Lambda, you have mail, you have SMS. Do you want to send message? The payload should be, everyone has to have the same payload or a custom payload. First, we'll go for a same payload, right? Okay, put something, right? It's just a message. Then you want to send any message attribute, you can also send that. Say, I say my message, my city, you want to pass some attribute to that, you can simply say this. Publish this message. Okay, as soon as you publish this message, what will happen? This is the message is published. Go back to your email and see if you got the message. See, I got my message, I got my email, my SNS topic, and this is what I gave there, right? So this is one type of subscription. When you subscribe only for email, you need to confirm the subscription. For SMS, for Lambda, you don't have to do that because that is done automatically for you. Okay. Now let's go and create another subscription. So this time I'm going to select a Lambda. We already have a Lambda function. So if some message comes here, and that will be passed as an event to that message, and use that event to do some processing, right? That's what we want to do. Go to your Lambda function, copy your function here and here, right? Please refresh here. Your DynamoDB trigger need to go off. Still there. Go to configuration and go to the triggers. Select this trigger and delete it. Close. Now your trigger is gone. Go and do a refresh. Okay, your trigger is gone. Copy this ARN and go put this guy here. Now let's see what will happen, right? I put this guy and I'm just saying create subscription. Okay, the subscription has been created now. Go back to the subscriptions. You can see one email, one Lambda, right? Now I'm going back to my topic. I'm trying to publish a message again. I will publish a message. This time I'll go for a custom payload. That means when my subscriber is an email, I need a different message. When my subscriber is a Lambda, I need a different message, right? So again, this one is, you can just say custom message from SNS, right? Keep this and go to custom payload. And this is what you have a template. Copy this template. Go to this one, okay? Just put it here. See what we have, right? Default should be there always. It's a failover default. So remove all the other stuff apart from Lambda and this one. So these are all the endpoints that we can have, and you can remove all these things. Keep the Lambda endpoints alone and remove this final. Okay, so this is what we are saying, right? So whenever it is an email, you send this message, sample for email endpoints, sample message for AWS Lambda endpoints, right? That's all. Just copy this. So what this will do, this payload will be delivered based upon different go and copy here, right? Default should be there without default, because if these two subscribers are not there, it has to fallback message will be this one. Okay, so if it is email subscription, it will be delivered as email endpoints. If it is Lambda, you can put your own message here, right? I'm just taking whatever is there by default. Let's go and see now, right? Again, I go and put my this one, and instead of city, now I'm saying my street name, right? Something random street, something. It's just a dummy street, right? Now go and publish. Let's go and see two things. Let's go back to my email first. I got my custom message. This is the subject that we have given, but see inside the body, we are getting only the messages that are pertaining to email. Okay, now go back to our CloudWatch logs. See, the function has been triggered. Go back down here and go to the last stream that you have and go and copy this and put it here and see what happens, right? The event is here. See the message that we got, sample message from AWS Lambda endpoint, right? So this is what, for each and every subscriber, you can send different what to say, different messages, and see the message attributes that we send. Based on this attribute, you can take some call, right? You can do something. If the street name is random, do something, correct? That you can do. You write your code in such a way, you read this message attribute, and if street is always random, then you have to do something in the table or send something, do something, right? Based on this message attribute, you can do that also, right? So this is how your SNS works. Any questions here, guys, for SNS? Okay, let's keep this SNS open. Let's go to and just refresh here. You will see your trigger now should be your SNS. Trigger should be your SNS now. Well, let's go back to our SQS, right? SQS is simple queuing service. That's what we saw, how to decouple things, right? You can create a queue, and either it's a standard queue or a FIFO queue. If it's a FIFO queue, always make sure the extension is .FIFO, right? Standard queue. Let's make this as my queue, right? My queue. Let's talk about these configurations, right? It's called a visibility timeout, right? Say, for example, in SQS, what happens? Okay, this is my message one, and I need to put it inside this pipe. So assume this is a queue. This is my queue, right? This is my queue, and this will be my consumer. Okay, this is my message. As soon as my message is produced by somebody, then if I go and set this visibility timeout as 30, what will happen? Until if some subscriber comes and picks up this message from the queue, for all other consumers, this will not be visible until 30 seconds. Within 30 seconds, if this is not processed, then this message will be visible to another consumer C2, right? For example, this is a C1, and it is taking the message M1. If it is not processing within that time, so once it has started getting this message, then another consumer like C2, C3, C4 will not have access to M1. That is, it's called visibility timeout. You can set this in seconds. It is basically from 0 seconds to 12 hours, right? Then message retention period is 4 days, right? It can be between 1 minute and 14 days. So what is that, right? So now assume that there is no takers for this message and nobody is able to process. This message can be in queue for this much time, 4 days, 5 days, 6 days. After that, it will move to the dead letter queue. Okay, so that is what this configuration is. Now delivery delay. Delivery delay, let me say you what is this delivery delay, right? As soon as the message is produced, before you send it to the queue, if you want any delay, right? So if I put 10 seconds, up to 10 seconds, this message will not be visible in the queue. It will never even get into the queue. Why you are doing that? If you wanted to do some other processing during that time, you can go ahead and do that. So that is called your delivery delay. Then maximum message size is of course 256 KB. That is standard, right? For any SMS messages, any message, it is 256 KB is what we can transfer at any point of time. Receive message wait time, right? Receive message wait time. This is the time, the maximum time, amount of time that polling will happen. So what will happen whenever you go ahead and your consumer is trying to go to the queue and search for the message. Okay, this is called a polling time. This receive message wait time is your polling time. Okay, so that can be between 0 and 20 seconds. So that means what happening, there is a two types of polling. One is called short polling and one is called long polling. Short polling and long polling. So what we are doing, short polling means if you are having this message timeout, message wait timeout, right, is there, right? You can make it 0. What will happen? Every time your consumer will go to the queue and keep on checking every minute whether it is whether it has got some message, it got some message. Again, keep in mind, for every time it goes to the queue, we have to pay something. So always make it as a long polling. Long polling, if you set it as 10 seconds, what it will do, the consumer will go there and wait for 10 seconds until if it receives any messages. If there are no any messages received within 10 seconds, then it will come back, right? So that time, that is that's the way that you can save some cost, because you don't have to do a short polling. You don't have to go every second to go check on the this one. So you go to the queue and wait for 10 seconds to see if any message is coming or not. That's called long polling. So this time will indicate that whether it is a short polling or long polling, and maximum it can go only for 20 seconds. Okay, it can go for 20 seconds. Again, if you are increasing this long polling to 20 seconds, this will also add time into your processing, because even though it gets the message, it will still be there in the queue. It will wait for the message, right? Then it will only process after that. So please be careful in putting this time. This will add to your customer user experience also, right? Access policy, just like what we saw, who can send messages to the queue, and whether only the owner can send or any specified account or users roles. Similarly, who can receive this message, owner or queue owner, or only any specified account, right? That's the same thing that we saw. Retry policy, how much time it can retry until it moves to a dead letter queue, right? Encryption, want to enable the encryption, you can go and enable it. So you need to create a queue and then come back here and select that as a dead letter queue. Okay, you can create that as a dead letter queue. You can enable the dead letter queue, create a queue, enable a dead letter queue, and then you can select the dead letter queue in that one. Okay, and then you can put a tag, that whatever tag that you want, right? So let's go and create a queue again, just with all these values. Leave everything default and just say create a queue. Create a queue. Now you can subscribe. Okay, you can subscribe this queue. Some message is coming, you can subscribe to the topic. That guy will keep sending you emails, right? That also can happen. You can subscribe to a topic. Let's try to see if we can subscribe to a topic, right? I already have a topic, so let's go and see if we can save this guy. So whenever a message comes, there is a SNS subscription. You can also trigger a lambda, right? You can also trigger a lambda. Let's configure a lambda trigger, create a function. We only have one function. We are going to only play around with that function, right? Now again, see here, the provided execution role does not have permission to call SQS. That means your role here doesn't have access to SQS. So what we will do, go to the permissions, go to this role and add an SQS permission as well, right? Add permission, add policy, and we wanted to talk about SQS. Click on SQS. So you can also select a lambda execution queue execution. This is the one that will get added, or you can go for full access. It's up to you. We'll go for this one, right? Attach this policy now. Now go back to your queue guy and try to save it, right? Go down here to Lambda, configure the Lambda. See, now you are able to save this. So now I have another subscription here ready. Okay, so that is fine. Okay, so this is my SNS subscription. That is also okay. Now let's go and try to publish a message. So you can send and receive a message. So this is what I told you. In the programmatic way, you will put it in your queue, right? So this I'm just going to send this queue. I'll just say Q1. See, delivery delay, I told you, right? Delivery delay, whether you wanted the delivery to happen immediately, just leave it 0, right? So what you do, send this message Q1, and you can see it will start polling for your message, and you will see your message here. Poll for messages. Okay. Ready to be received. I think it's already doing it. Let's hold on for a minute. So every time you poll, you need to pay. Okay, so please be careful. Free tire, we don't have to worry for now because free tire is already we have. So what happened? Is this message sent or what? Okay, message is here. Let's go back down and check here. What happened? Did we receive something? Nothing came from SNS. Nothing came from SNS. Go back to the CloudWatch. Have any streams updated here? This is done, I believe, right? See here, received handle, message ID. This is the message ID that we got. The body of the message says Q1. That's all. So you get this message and you start doing whatever stuff that you wanted to do on this messages, right? So subscription, the Lambda has taken the subscription correctly, but our SNS topic has come here, but it did not trigger our email. So we need to check why is that, right? Okay, that's fine. Anyway, this is what your polling will do. Let's go and do a Q2. And this we will make it 5 minutes and send this Q2 message. Okay. If you go to the CloudWatch, you will not be seeing this immediately. Only after 5 minutes, it will come into the queue. Okay. So that is the message delay that we have, right? So you can get into these messages and you can start doing all this stuff. Then you have this one, and if the messages keep on trying, it's not doing, you can go and make it as a dead letter queue and you can put it in that queue. You can create another queue called DL queue and configure here, so it will get into that queue if nobody is able to process that message, right? Then monitoring for all SQS, again, just like SNS, everything will happen through your CloudWatch. Okay, so everything will happen through CloudWatch. Tagging, it's optional. Access policy we already saw, like who can publish the message, who can consume the message, right? So, and you can also see the read write policy. Or read write is nothing but read write policy. Encryption, you can enable encryption, and these are the dead letter queue read write tasks. What are the things that we retried in our dead letter queue, right? So this is what you have for your queues, and this is your simple queuing service. You don't have anything here, right? In this place, you simply have only one to create a queue. That's all. And once you create the queue in your programmatic way, you can call this ARN and publish the message to this queue. Okay, so this is what we have for our sessions today. Okay, Any questions, guys, before we just go and clean up? So with this, we are done with all our core services and everything. So it's now you guys have to start practicing or start doing it, right? Just give me 1 minute. Let me just quickly remove this off, and we will go through some other certain things that you need to do, right? See here, both your SQS and SNS, both can be your subscriber. Okay, so lambda function is fine. Now go back to the SNS, go to the topics, and make sure you delete the topic. Okay, fine. So this is what we have for our sessions. So I want to just let you know some other things, right? Like if you are planning to write your exams or something, these are all some of the links that you can just see. Like this Jayendra Patel blog is very good, and these are all Amazon's official site where you can use for documentation purpose. And you can also get this question banks from John Bonzo in Udemy. These question banks, there are 6 or 7 sets of questions there, I believe. Like it looks like real exam. It's more tougher than the real exam. So if you are able to get consistently 85% in this exam, then you will be able to pass your exam very easily. Okay. So, but very important, these are all scenario based. Please practice, keep practicing, practicing. Right. So, any questions that you guys have? Anyone?
So Chandra, one thing, like you have given the link for John Bonso like that. So is there
Right.
any other links also where we can get it like freely
No,
available?
free.
Not in
You can search.
Udemy.
No, you can search in the Google. But this John Bonso
Hmm.
is a paid one. This is the most trusted one, and all the students
Okay,
have given reviews that once they complete this, they are very comfortably to pass their exam.
okay. Yeah, yeah, we'll subscribe for that only.
Yeah, and
Yeah,
one more thing is with John Bonso's exam, this one it gives you explanation why one particular answer is wrong, why particular answer is correct. It will give you full explanation, so
okay.
you can test your understanding on that particular service as well.
Yeah, correct.
And I've already uploaded question banks for you, whatever that I got it from some place, right? So you can use that to go ahead and check your this
I
one, right? So for yeah,
I think you have put for 3 topics, no?
for VPC, for RDS, and for EC2. So
Okay.
those are
So
the
do you
three
have
things I
some
just yeah. If I have
more
something, I will.
topics?
Yeah, if I have some, I'll put it there. But please go ahead and check out at least the ones that I have put it and see if you guys are able to kind of crack those things, right? So that's very important, right? So we can go, if you go
Yeah.
to get into VPC questions, for example, right? So if you would have already know this, like this is what you have, right? Let's take one from here and see what is happening, right? So please be very careful. All these are like scenario based. So you are an AWS architect and you can do it too in corporation. You have been tasked to design and launch EC2 NAT instance in public subnet in your client's VPC. After creating and successfully testing NAT instance, you have also updated the private subnet route table such that the NAT devices in the target traffic destined to the internet. However, the private subnet in EC2 still are not able to connect to the internet for updates and patch download. So what might be the reason, right? That's what you need to find out. NAT instance launched only with one ENI. NAT instance has not been configured with proper NAT rules. NAT instance will not work. You need to configure static one-to-one NAT VPC internet gateway for private instance, disabling the source destination check attribute on the NAT instance. Okay, what is the correct answer? See here, it is a NAT instance, not a NAT gateway. So I told you when we talked about NAT, you have to disable source destination check, otherwise your NAT will not work for NAT instance, right? So this is the right answer for this particular question. All these are wrong because NAT instance is launched only with one ENI. NAT instance doesn't do anything. It launches with one ENI. That it's just an instance, nothing to do with ENI or connecting with that. It's just a network interface card. NAT instance has not been configured with proper NAT rules. Above it says you already have all the rules here, right? See here. Device is the traffic and everything is correct. So nothing to do extra. NAT instance will not work. You need to configure static one-to-one NAT internet gateway. It already says it's connected to the internet gateway. Okay, internet gateway. It's already connected to internet gateway. So the only answer is this one. You need to make sure you disable the source destination check on your NAT instance. If you go back to our, let me show you where in my deck this particular thing comes, right? So that way you know, like whatever that we are talking in lines with this only, right? Go back to AWS, go back to this one. Let's go to the VPC and I'll show you where I put this, and I highlighted this for you specifically. So you need to be thorough with what we have done so far. This is what we did, right? See, when creating a NAT instance, always disable the source destination check for the instance. If you don't do this, you will not be able to connect a NAT instance. Whereas in NAT gateway, it is a managed service. You don't have to do that, right? There is nothing. But here, that's why when you simply say NAT, please watch out for the word whether it is instance or gateway, right? So this is how you need to tackle your questions. Okay. So at which instance, can the source destination can be changed? When it can be changed? So when it is running or when it is stopped, you can change that, right? And this is another one interesting questions on the CIDR block, right? So only if you go through the materials that we have given you or whatever that we have, right? And whatever that we have seen hands-on, if you go through that, you can see. So you have created a VPC with CIDR 10.00.24. The VPC has two subnets, 25.25. For an anticipated project, you want to increase the CIDR range of your CIDR block. How can you do this? Change the subnet to 28 once you, okay, and then you can always change the VPC's original CIDR. You can add additional CIDR, delete all the subnets and start from scratch, right? What will be the right answer here? You cannot change the subnet settings once you create your CIDR. So this is gone. This is wrong. Okay. You can always change the CIDR. You cannot change it. You cannot do the original CIDR block. You cannot go back and change it. You can go and check that. You cannot edit the existing CIDR block, right? So just go back, quickly check, right? Go back to this VPC. You have to think about this, right? Only if you have worked on this VPC, creating VPC and know about CIDRs, it will be very easy for you to answer these questions, right? Otherwise it will not be. So go to this default VPC I have. I'll go and edit my CIDRs here. Can I add this? Can I increase this? Can I remove this? I cannot do anything, but I can add an additional CIDR, right? I can add an additional CIDR, and that is the correct answer. You can add an additional CIDR. I want to add an additional CIDR as, like, say 10.0.0.16, right? And I can save, and I have an additional CIDR, but this is restricted because it is actually using a private address range. So you can go and add a additional CIDR block you want to add. This is for restricted in default. This one you can go and put your own, this one, right? So you can go and add your additional CIDR block if you want that. So that is the answer for this. So unless you have worked on this, you will not know, right? And this is the fourth option is weird because you cannot have all your applications now delete and recreate everything from scratch. You cannot do that, right? So the only way to do is to add additional CIDR and get that CIDR range also, right? So these are some of the things that you need to take care, and you can go and start doing, right? So you see some questions like this, so many big questions, very simple. All that you need to understand the question. If you don't understand, then it's very difficult to answer. So you are an AWS SME at some corporation. Your sysop administrator created a VPC with public subnet. He created and attached an internet gateway to the VPC and launched an EC2 instance with public IP. He also created a security group for the EC2 instance. When trying to connect to EC2 instance from internet, he was not able to. From the statements below, which could be the possible reason for his inability to connect, we have to choose two. So what might be the issue? He has created an internet gateway. He has created a public subnet. He has attached it. All that is fine. What is done? There is no entry in the route table to the target. This can be one of this one. Admin did not configure security group. It says security group is there. So we can remove this. And then security group is denied. He says security group is configured in such a way to allow. That's also gone. So it can be either this one
D or D.
or D.
Yeah.
If in knuckle, it might not have had the correct this one. So these are some things that you can go through and you can see this. Okay, so I've put some questions there. I've given you, I will upload this exam tips PPT as well, so you will be able to see everything. Okay, so with that, we close this, and all the best for your exams. If you have any doubt, please ping me in WhatsApp, and I will get back to you. When you are pinging, please ping your name and say you are from Besant 7 AM batch, right? So I will immediately relate to our batch, and I will try to help you out whatever you need to do, right? The next thing I'll have to let you know is, like, yesterday I provided some link which is not working. So Abhinav told this is the link that you can use to give the reviews on your coordinator and trainer and about the course. So I have already pasted this in our group chat. I will include this in the email also. I'll be sending email to you all in your Gmail address. So please go ahead and acknowledge that course has been completed today, and please give your feedback. Or then also please refer your friends, and please ask them to talk to me if they need to learn anything in AWS, DevOps, Terraform, or Docker and Kubernetes, right? All those things you can please refer and give your feedback on this, and that will be really helpful for other students and for us also to move forward. Okay.
Yeah. Chandra, for DevOps also you are giving training? I mean,
Yeah, DevOps
these
also I take
topics.
DevOps, yeah.
Because
DevOps.
I have taken that also, DevOps also, so I will definitely go with your
But I don't know
training
whether
only.
I'll be your trainer or not, because it depends on, like, when my next batch starts on DevOps. Okay, so you can
I will
check with
try
the,
to ask.
yeah,
Yeah, I will
try to check
try
with the
to ask
coordinator.
him.
Yeah,
Yeah, sure.
check with the coordinator, and based on the batch, then they will kind of put you in that. Okay.
Yeah, sure.
Okay. Any other questions you guys have? Please let me know any questions that you guys have. So I have uploaded all the things that we have seen so far. So only today's deck and recording is the one I need to upload, which I will upload it after this class, and I will send you an email. Watch out for the email in the next couple of hours, and please go ahead and give your valuable feedback. That will really help me to kind of improve my way of delivering AWS for the next batch, and I will take all your inputs. It can be anything that you want me to improve, uh, any areas of improvement in my delivery or in my subject or in my hands-on. Please let me know. I will take that feedback positively, and I really appreciate all of you taking time and patience to join my course, and patiently hearing me out for throughout the course, right? So, and thanks, and please proceed, and don't stop with this. Always keep learning, keep updating yourself with all the technologies that are coming there latest, so that you will be in the race and you will not be left out. Okay.
Yeah,
All
sure.
right.
Thanks,
So
Chandra.
thanks everyone. And if we happen to meet in any other course, any of my course, we will talk there. If not, have a great career, and please keep me posted if you have passed your exams, or if you have any questions, or if you're already working in AWS, you have any questions or any queries, any doubts, please let me know. I will try to help you in a way, whatever way that I can. Okay.
Yeah, sure. And Chandra, please upload that exam tips also. And
Yeah, I will be uploading those exam tips, and there is a blueprint also. I will upload this
okay.
blueprint, but please check out for the new blueprint in the official site. Okay, I've given you the site also. Please go and check on the official site, because that they keep on
Yeah, sure.
changing it. Okay,
And
fine.
Chandra,
Yeah,
one
sure.
question.
Yeah. Yes, Rajesh.
Yeah, the exam pattern is changing after this month.
Yeah, it has normally changed. So they have added some additional services around, like the pattern is the same. The pattern is going to be 65 questions, 130 minutes, and it will be like all situation based. They have added some additional services which it may come like 10% of the questions might come in the new additional services, but still with this we will be able to crack the exam and pass and move. But if you still wanted to look at those services also, you can go and take a look at yourself. If you have any doubt, please let me know, because those services are just added recently, and those services you can learn from the documentation itself, because it's not going to be much in the exam, at least to begin with, right?
Okay. Yeah.
Okay, so but my humble advice for you all is, please download all my materials including the video and have your free time, and please work out on these tasks so you get used to, and you will be able to answer all your, see, since I'm reading the questions for you and I am highlighting these are the places you need to look at, you are now able to answer few questions. But when you do it for yourself is where you need to be very careful and very thorough on those topics, otherwise it will be very difficult for you to kind of get these things right. Okay, try to crack your exams on the first move itself, right? So you have to score minimum 720 points out of 1000 points. Okay, 72%. Okay, so all right, guys, thank you everyone for your time and support and patience, and I would uh, really like to meet you all in any other course that we will meet. If not, also please keep in touch, and whenever you have any queries, even before you go for an interview, you don't know what to prepare for, and right, please give me a call. I'll try to help you how to prepare as well. Okay, and if there anything else that you need to talk about the course or something else, please connect with your coordinator, whoever is, I think it's Chitravel, whoever is your coordinator. Please get in touch with him, and you can, you want to learn more courses with this Besant technologies, get in touch with them. You want to contact me privately also, please call me, no issues. Okay. Okay.
Yeah.
All right, guys. Yeah. Thank you. Thanks everyone, and all the best for
Thank
your career. Yeah. Thank you. Yeah. Thanks all.
Thanks, Chandra. Thanks all.
Yeah, thank you. Bye.
Yeah, thanks.